Hello again. So today we're going to be talking about polymer chemistry. Polymers are covalently bound or covalently linked molecules. They're long chains of these covalently linked molecules. And we use polymers for a lot of applications in our day-to-day life. They have dramatically changed, they've dramatically improved many aspects of our life. So hopefully you'll get to experience some of these polymers and you get to see some of the exciting things that they do. Okay, so as I mentioned, polymers are these long chains of covalently bound atoms. They can be millions and millions of atoms long for a single chain. And so we typically think about these long spaghetti strands. This right here is this is a polyethylene, which is what we basically make shopping bags out of. So in general, although there are many kinds of polymers, and we interact with polymers all the time, they're all made in a similar way. They're made from monomers. And so what you want to kind of think about is you want to think about maybe the way in which you take individual pearls, and then you would kind of string them along and make a pearl necklace. The pearl itself would be the monomer, the individual unit. And then as you strung the necklace up to make the long chain, that would be the polymer. And so you can kind of see that here. So this is our monomer maybe. And so in this case it's white circle, black circle. And the polymer would be all linked up. And so this would make a new bond there, and a new bond there, and a new bond there. And ultimately you would get this kind of long chain polymer. So a good example of this, as previously mentioned, is polyethylene. So you start with ethylene. Ethylene is the mer units, and you undergo a chemical transformation, and the double bonds go away, but you get new linked up single bonds, and you get a whole bunch of CH2 groups in a row. And this is, as I said before, what we make a lot of our products out of, including things like shopping bags. Now with polyethylene, it really is just carbon and hydrogen in a polymeric form. Often, though, when we want to impart some kind of function or some new property to the polymer, we are going to add on some side chains. And so we're going to polymerize something with some groups off of it, some functional groups or something. And so to give you some examples of this, if you were to polymerize a monomer with fluorines on it, and so these fluorines give certain properties, and polyfluorinated polymers, such as Teflon, tend to repel lots of things. Fluorinated polymers tend to repel both water and grease, and so we use a lot of fluorinated polymers on our non-stick coatings. Additionally, a lot of our active outdoor wear has fluorinated polymers. It's typically soaked in fluorinated polymers, and this imparts an additional amount of water repelling ability. On the other end of the spectrum, you might have a polymer that has functional groups that are very water attracted. So this is a polymer right here. This is kind of a graphical picture of a polymer. You can kind of see it's snaking around here. But what it has these carboxylate groups on it. This is sodium polyacrylate, and it's covered in these carboxylates. And these tend to bind to water very well. So we think about these sodium ions. These sodium ions, of course, can interact with water molecules just in the same way that ionic salts would, and so this tends to grab and hold on to a lot of water molecules, which means that this polymer is really absorbent. So one of the applications of this polymer is that we stuff this polymer into diapers, and the diapers, when a kid goes to the bathroom, all the water gets soaked up, and these polymers can absorb many times their own weight in water. Now, one of the most important recent developments with polymers is that we are now really making a lot of efforts towards recycling polymers, and so depending upon the polymer, they have to do a different kind of recycling technique. But most of the polymers, such as polyethylene terephthalate, high density polyethylene, those are shopping bags, polypropylene, these are often all just simply, after they're sorted and they're washed and they're decontaminated, they're separated, and then they're actually melted. So they're melted back down. You can remember this is kind of like a bowl of spaghetti. They're melted back down so that the strands are moving freely, and then they're remolded into a new object. So then maybe they're remolded into a new plastic bag, for instance. And that's really what recycling is about. Other ones, they have to do a different technique. Sometimes there's a chemical technique that they ultimately utilize, and some are not as easy as others to recycle. And so you want to check with your city system as to what you can and cannot recycle. But there's a numbering system right here you can see, and this numbering system lets you know the chemical formula of what it is composed of. So you can see that a lot of the plastics that we utilize on a day-to-day basis are really just a handful of polymers. Polyvinyl chloride, so you can imagine that has chlorine atoms hanging off of it. Polypropylene, this has methyl groups hanging off of it. So each one of these corresponds to a chemical structure.